Okay, so in this video I've got a very interesting problem for you. So in earlier classes you must have learned how to find the area of simple shapes like triangles, rectangles, circles and all. Okay, and using that knowledge we could also find the area of much more complicated shapes like for example, if I give you this shape, you can find the area of this shape by finding the area of the triangle and the semicircle, and then adding both the two together and finding the shape of the area of this shape. Okay, so that is a very useful trick to know. Also, in earlier classes, you had an activity where you had to find the area of a circle. So what you were supposed to do is divide this circle into many triangles. So actually, these are not triangles; these are actually sectors. If you remember, they're actually sectors, right? But if you draw many triangles, this arc here approximates a straight line, and if it approximates a straight line, this sector is almost equal to a triangle. So we can assume that it is a triangle if we have many triangles. Okay, so that's why you are supposed to divide this into many triangles, and then we simply cut the shape into cut the circle into triangles, rearrange those triangles to get a parallelogram. How? I took this triangle, keep it here. Take the next triangle, keep it upside down. The next, okay, this the same way, and so on and so forth. I continue until I reach this. Okay, so I get a parallelogram, right? This is a parallelogram, and the area of this shape and that shape is the same because they are made of the same amount of paper. Now, if I could find the area of this shape, I get the area of that shape also. What is the area of a parallelogram? Base times the perpendicular height. So what is the base of this thing? That will be half of this length. Why half? Because we've got half triangles upside down and half that are kept straight up, right? Okay, so this length here is 2 pi r, the circumference of a circle. Half that you get pi r. So this whole base is pi r. There you go. And the height of this parallelogram is the height of the triangle, right? And the height of the triangle here will be this much, and this here is the radius of the circle. So this height becomes r, radius. This is r, okay, radius. And if I multiply the two, I simply get pi r into r, which is pi r square, and that is the area of the circle. So that is how we got the formula to find the area of the circle. Okay, so that is also a useful piece of information and a very interesting technique to find the area. Now, with that being said, let's get to the problem. So the problem is, I've got a function. I've got a graph of x square. Okay, this is x square here, x square, and I'm plotting x here, x-axis, y-axis, and all that stuff. And I take two boundaries. Okay, I draw two lines. Okay, from the x-axis to the curve at x equals 1 and at x equals, let's say, 2. I'm just telling the problem right now. Okay, so this is the problem. Somebody tells you, okay, so this is the problem that somebody is asking you to find out. And being a mathematician or being a general student, science student, you need to be able to do this. Okay, because this is actually a very useful thing to know. So yeah, so here I've got a closed figure, right? And every closed figure has some area. So even this closed figure, right, this shape here, right, this shape also has some area. And now our job here is to find the area of this shape. So we know that we don't actually know any formula to find the area of such a complicated shape. Okay, but we can use a simple old technique of dividing this into simpler shapes and finding the area of those simpler shapes, adding them up, and probably we can get the area of this shape. Okay, and just like in the case of circle, our area will be an approximation because we have to make some approximations. Okay, but we'll have to find ways of making those approximations better. So we'll come to that point later. First of all, so what is the simplest shape that we know of? A square. So we could divide this into many squares and find the area of each square, but that is a very tedious task. There will be many squares and it will just be too difficult for us. Okay, we are a bit calm-chore. Okay, so we'll just divide this into many rectangles because I think finding the area of rectangle will be a bit easier. We'll also use trapeziums, but then the formula of formula to find the area of a trapezium is a bit complicated, and then you get into a lot of tedious tasks, and it'll be complicated. So I think rectangles is the perfect shape. It is simple and also easy to make. Okay, so let us go with rectangles. So let us make first of all 3 rectangles. Divide the shape into 3 rectangles. I'll try to keep the width of the rectangles same. Okay, just to avoid complication. Okay, it's not compulsory, but let's try. Okay, first rectangle, the second rectangle, and the third rectangle. This I've got 3 rectangles: first, second, third. Okay, so yeah, so I've kept the width of the 3 rectangles same. Now I still have some area left here. Okay, if you can see this area, and this area, small triangles left. Okay, so if I find the area of this rectangle, these 3 rectangles, add them up, I won't get the exact area of the original shape, right? But it'll be close, but not the exact area, right? So there again we have to make an approximation that the area of these rectangles will be the same as the original shape. But I think we can make the approximation better somehow. Okay, so let us try and do something. We increase the number of rectangles and let's see what happens. So instead of making 3 rectangles, let's make 6 rectangles. So I'll just make 6 rectangles. Okay, I'll just divide them into each rectangle into 2, and then let's see what happens. Okay, this first rectangle, the second rectangle, third, 1, 2, 3, 4, fourth rectangle, fifth rectangle, and the sixth rectangle. Now pause the video and go and just rewind the video a few seconds behind, and then just compare. Even here I've got some area left. This. But I'm pretty sure this area that I've left this time is much more less than the area that was left in the previous case. And if you don't trust me, just check it for yourself. And now, if I increase the the number of rectangles even more, I can get a better approximation. I can reduce the area left, and I can reach a point where the rectangles are pretty thin, but my approximation is decently good. Okay, so right now I won't increase the number of rectangles. Why? Because it's pretty difficult for me to draw them. Okay, I'll stick to these number. Okay, these many rectangles, and let us assume that this approximation is pretty good for us. Okay, obviously we have to increase the rectangles in a real life situation, but let us stick to this case first. Okay, if we can find the area of these rectangles, it'll be a good great achievement for us. And in the module that I've attached with this, I've made some diagrams, and I'll clarify it there also. Okay, so our now aim left is to find the area of these rectangles. Okay, so let me just isolate these rectangles and forget the curve and all. Okay, if I could find the area of the rectangles, I simply get the area of the curve, the weird shape that I've chosen. So let me just make these rectangles again. I have 1, 2, 3, 4, 5, 6 rectangles. I'll try to replicate them. 3, 4, 5, 6. Right? So I try to make them pretty similar. So I have to find the area of these rectangles. So one way is to measure the height of each rectangle, multiply with the width, find the area, add them up. But remember, our aim here is to increase the number of rectangles, right? And if there are many rectangles, here we have just 6 rectangles. But what if I had made 100 rectangles? This technique is not very feasible there. So let us find some easier method. Okay, so what we can do is we can actually okay, so if you had drawn this on a piece of paper, what you could have done is you could I'll just show you that thing. Wait, I could cut this extra piece. Okay, because this is the tallest rectangle, right? So I just cut this piece using a scissor. Okay, if I had drawn it on a piece of paper using a scissor, I would cut this piece, and I take that piece and put it here. And by doing similar cutting pasting, I can get all the heights of all the rectangles to be approximately similar, right? I hope you can do that if I had given you the task. And like so I take it and put it there. And one thing you should notice is Okay, let's just do it here, okay, directly. So again, I can, these two are the tallest here, so I just cut them again and make these three equal this time. And I have got two pieces, right? Now I stick those two pieces here and here. Now I take these three, and let's say I half their height. I half their height, and look, I just cut that piece again and I stick it here, here, here. Okay, obviously I have oversimplified the process, but this is what generally has to be done. And I end up getting what shape? A rectangle. This is a pretty simple rectangle. And I know how to find the area of a rectangle, right? Base times the height. And I know the base. Okay? This, no, I hope you can guess what the base is. No? This length is equal to this length, right? Because this is the same shape, right? And what is this length? This is 1, this is 2. So the difference is 2 minus 1, 1. So I know this difference. I know this length. And this length is the base of this thing, right? And that is, in this case, is simply 1. So I know this. Okay. Now, what is the second unknown left? The height of the rectangle. That is a tedious part of this whole exercise. I need to find a method that can tell me the height of this rectangle. Because I don't know what the height of such a rectangle is. So I think that is it for this video, and in the next video we'll find a method to find the area of the height of this rectangle. And if I can find the height of that rectangle, this rectangle, I can multiply those two numbers, get the area of the rectangle, and the area of the rectangle has to be the area of these rectangles, okay, summed up together, and the area of these is almost equal to the area of the complicated shape that we had. So that is how I can proceed, and let's continue the next video.